Okay, so we're going to do the math to find inverse functions. And the first thing I want to know is what is the notation for an inverse function so that when I'm done with finding these functions, I know how to notate that. And what I would do is I'd say, well, the inverse notation for, or the function for an inverse function, that's my notation right here. So my notation is going to be f to the negative 1 of x. That's how I would write down this equation that I figured out is the inverse function of what I started with, and that's how I'm going to write it. So if I'm given some function, this guy right here, I'm going to put this in orange, this guy, and I want to find the inverse, what I need to do is switch its x and y. So I'm going to take this guy, I'm going to switch it with that guy. And so I'm going to have x equals 5y. And then I'm going to solve for y. So I would divide by 5 on both sides, and I get x over 5 equals y. So I've got y alone. But the way that I write it in this inverse function notation is I would say f of negative 1, or f to the negative 1 of x equals x over 5. And that's the answer. That's how I write. This is the inverse of the given equation. Okay. If I want to find the inverse of this equation, it's written just a little bit differently. Instead of having a y already given, it's put in function notation. So I'm just going to change this to a y equals x minus 7. And then what I'm going to do is I'm going to switch the x and y places. So I'm going to say, well, this guy and that guy need to change places. And I write down my x equals y minus 7, and I'm still solving for y. So I'm going to add 7 to both sides, and I get x plus 7 equals y, but I want to write this in inverse notation, so I go f to the negative 1 of x equals x plus 7. Okay. I'm going to find the inverse of this guy. I need to rewrite this with a y instead of an f of x, just so I can switch the x and y places. And I'm going to say, well, these guys right here, they need to switch. And I'm going to rewrite that over here and say that x equals y minus 8 over 3. And the first thing I'm going to do is I'm going to clear my fraction. I know that if I multiply both sides by 3, I can get rid of that guy. So I'm going to say, well, times 3 and times 3 on both sides of my equation, and that'll cancel out. So I get 3x equals y minus 8. And then I'm going to add 8 to both sides. So I add 8 to both sides, and I say 3x plus 8 equals y. And I can't add the 3x and the 8. They're not like terms. So that's where that ends. And I'm going to rewrite this in my inverse function notation and say 3x plus 8. Okay. Here we'll do this one as another example. I'm going to change this to y equals negative 2/5 x plus 1. Again, I need to switch these guys places and say that my x equals negative 2/5 y plus 1. I'm going to clear my fractions again just to make my life easier. So I'm going to take both sides of my equation and say, I'll do this in purple again. So if I'm going to do this, I'm going to take both sides of my equation. I'm going to multiply by 5. It'll get rid of that 5 in the denominator. I'm just having to distribute through on this side. And I'm going to end up with 5x equals negative 2y plus 5, because these ones cancel out. And I still want to get my y alone, so I'm going to subtract 5 from both sides. And I get 5x minus 5 equals negative 2y. I divide by 2, I divide by 2. And I get 5x minus 5 all over 2 equals, divide by negative 2, equals y. And so I'm going to write that in function notation, say f to the negative 1 of x and I get 5x minus 5 over negative 2. Okay. When I'm finding the inverse of y equals x squared minus 9, I have to restrict the domain. I'm going to have to look at it, and when I have a u, right, I'm going to say that I'm going to only talk about one side of this, so I'm going to only really talk about this side of it. And that way I can say, well, it's just going to be living in 1/2 of this, so that when I do my inverse function, it will pass the vertical line test. So it won't pass the horizontal line test because it goes through twice. So I'm going to have to restrict the domain. But I'm going to do this, I'll just do the math for now and say I need to switch these two things places and say x equals y squared minus 9. And when I do this, I end up with adding 9 to both sides, and I get x plus 9 equals y squared. And when I take the square root of both sides, I get x plus 9 square root equals y. Now, we would have the plus or minus, but if I restrict the domain, I'm only going to deal with 1/2 of this, so I'm going to say my function is going to be the square root of x plus 9. So technically, I could do two things. I could have also a function that has the negative of this, because when you take the square root of things, you get the plus or minus. But that would mean I'm dealing with one side of the equation, and so you're dealing with 1/2 of this and then another half of this. So each one at a time in order to do that. And the last one I'm going to do, as I'm going to put this as a y equals x plus 4 to the third minus 6. Again, these two have to trade places, and I would go x equals y plus 4 to the third minus 6. I'm going to add 6 to both sides. I get x plus 6 equals y plus 4 to the third power. I'm going to cubed root both sides, and that will make those cancel out. And I get the cubed root of x plus 6 equals y plus 4. And then I subtract 4 from both sides, and I get the cubed root of x plus 6 minus 4 equals y. So my function, my inverse function, is the cubed root of x plus 6 minus 4.